Hey everyone, welcome back to our physiology lab. Today we're diving into a classic experiment using Beer's law to figure out the concentration of an unknown solution. And I'm excited to walk you through it. Before we get started, here's what you'll need. We are going to measure the concentration of our unknown glucose solution by using Beer's law. In this experiment, we need test tubes, glucose reagent. The glucose reagent we needed to confirm the presence of glucose in our unknown solution before proceeding with absorbance measurement. We need glucose standard solution. We have glucose unknown solution, which today our goal is to measure the concentration of our glucose unknown solution. Wax pen, distilled water or deionized water, graduated cylinder, microliter pipette, test tube rack, and then 37 degrees centigrade water pass, parafilm, and here we go. That is our spectrophotometer, which we need to measure the absorbance of our solution. And here it's our Beer's law. The CS concentration of a standard solution divided by absorbance of a standard solution equals Cx, which is the concentration of our unknown solution, divided by absorbance of our unknown solution. So we are going to measure the absorbance of our standard solution and then unknown glucose solution by using the spectrophotometer, and we already have the concentration of our glucose standard solution by reading the label on a bottle, and then we need to calculate the concentration of our unknown solution. Let's get started. The first thing that we need is to turn on the spectrophotometer to allow it to warm up, and then obtain 3 test tubes and label them with a wax pen. B for blank solution, U for unknown glucose solution, and S for standard solution. Then we're going to add 5 milliliter of glucose reagent to each tube using a graduated cylinder. And then we are going to look at the bottom of the meniscus to make sure we have an accurate measurement. So what is the glucose reagent? As I mentioned before, we are using glucose reagent to confirm the presence of glucose in our unknown solution, and then we can go ahead and measure the absorbance by using the spectrophotometer. So as you can see, our glucose reagent the color is orange, and then if there is glucose in our solution, the orange color would be changed to red. So the first step, we need to add the 5 milliliter of glucose reagent to each of our B, U, S, U2, blank, unknown, and standard solution. Next, we are going to add 50 microliter of each of our solution, like we have water, unknown solution, and glucose, the standard glucose solution, by using the microliter pipette. So our blank solution is going to include the glucose reagent, plus deionized water or distilled water, which we will use the blank solution to calibrate the spectrophotometer. We'll calibrate our spectrophotometer to ensure the accurate reading. So the purpose of having the blank solution is to calibrate our spectrophotometer, so we make sure that our reading would be accurate. Then we have our U solution or unknown solution, which we added the glucose reagent, and now we are going to add our unknown solution. And our purpose is to measure the absorbance of this solution by using the spectrophotometer, and finally we are going to measure or calculate the concentration of our unknown solution. And then the last U-tube, which includes the glucose reagent, and now we are going to add the standard glucose solution. Next step, we need to incubate our test tubes for 20 minutes in 37-degree water bath. Let's see what we're gonna see. Then after incubation for 20 minutes and after like shaking our test tube and mixing them with their ingredients, we are going to see some color changes. So as you can see in our U-tube or unknown solution tube and a standard solution tube, we can see the color change from orange to red. But our blank solution, the color is not changing. Why? Because there is no glucose. Our blank solution, it contains only glucose reagent and distilled water. So there is no glucose. Then, but our unknown solution and standard glucose solution, their color has been changed from orange to red, which it shows us that there is glucose inside of this solution. Okay, so then glucose reagent will show which color if glucose is absent. Like in our B test tube, it shows orange. Why? Again, because there is no glucose. If there is glucose in our solution, then the solution color would change from orange to red. When there is no glucose, our solution color we're not going to change, and then we can see the orange color. But what about if our glucose reagent show the red color? It means glucose is present. So it means that, so we knew that our standard glucose solution, it has glucose inside, but we did not know, or we did not make sure that, do we have glucose inside of our unknown glucose solution? It means yes, we have the glucose inside of this. And now let's go and measure the absorbance of light for each of our tubes or solution. We're using the spectrophotometer to measure the absorbance of the standard glucose solution, unknown glucose solution, and also we are going to use the blank solution to calibrate our spectrophotometer to make sure our readings are accurate. But it's so important to mix the solution and clean it with a Kim wipe before you place it into the spectrophotometer. We are going to set the wavelengths of the spectrophotometer to 500 nanometer and then calibrate the spectrophotometer using the blank, and we are going to set to the zero absorbance. What does it mean? It means that then you need to write it down. The absorbance of our blank solution would be 0. Because we calibrated our spectrophotometer by using the blank solution. So then make sure you know the absorbance of blank solution is 0. And then we are going to measure the standard glucose solution absorbance and also our unknown glucose solution absorbance. So you will have two numbers here. After using the spectrophotometer and measuring the absorbance of these two solutions, and see what we're gonna have. Now we are going to see what is our Beer's law one more time. Beer's law is the concentration of our standard solution divided by absorbance of our standard solution equals the concentration of our unknown solution and absorbance of our unknown over absorbance of our unknown solution. We are going to calculate the concentration of our unknown solution. We need to have these three numbers, CS, AS, and AX. Okay, by using the spectrophotometer, we measure these two numbers. Let me go back. So here, at this step, we measured the absorbance of a standard glucose solution. It means that now we should have a number, whatever it is, as AS. And then now we should have the absorbance of our unknown glucose solution, which will be the AX. So what does that mean? It means that now we have these two numbers as well. But what about the CS, or concentration of our standard solution? We have this number, because if you look at the bottle of our glucose standard solution, you will see this number, which it shows the concentration of our standard solution, which based on the solution we use, the concentration of our standard solution is CS, it's 100 milligram per deciliter. So it's important to put the unit. And then let's go back. So here we have 100 milligram per deciliter as concentration of our standard solution. And also we have these two numbers which absorbance is unitless. You don't need to have a unit for these two numbers. And then we are going to calculate the concentration of our unknown solution. So it means that you should multiply 100 milligram per deciliter times AX, whatever number that you have, divide by AS, the absorbance of a standard solution, then the number here would be your concentration of our unknown solution. Okay, I hope you enjoyed this experiment as much as I did. Stay curious and keep experimenting. Thank you for watching this YouTube video.